Now let us discuss properties of electric field intensity. So first it is a vector quantity. Electric field strength or electric field intensity is a vector quantity and its direction is same as the force experienced by positive charge, not the negative one. And next is electric field due to positive charge is always away from it, and while due to the negative charge is always towards it. So basically idea is that, let us say this is a capital charge Q which is positive. Here I have to check the electric field intensity, the direction of electric field intensity. What you do is you put another positive test charge. This is a test charge and it will experience force in that direction. All of us know that this is positive, so force will be repulsive and force will be in this direction, and whatever is the direction of force, same direction will be the direction of electric field. What if this is the original charge is a negative charge? So we will say that I want to check electric field intensity at this point. So put a positive test charge and check the force. So this negative charge will attract this positive charge and eventually this is the direction of force. So we'll say direction of electric field intensity is same as this force. So due to positive charge, it is away from the positive charge itself, or we can say radially away, and due to this negative charge, it is towards the negative charge. Now next point is its SI unit. So as we have already discussed, the formula for electric field intensity is force experienced per unit charge. So force is Newton and the charge is Coulomb. So SI unit is going to be Newton per Coulomb. What about dimension? So its dimensional formula is ml t raised to minus 3 a raised to minus 1. So I am finding it in front of you. So basically electric field intensity is nothing but Newton per Coulomb. Now Newton is what? Newton is kg meter per second square. And what about Coulomb? We already discussed when we were writing initially the dimensional formula for K. So Coulomb is not SI, we need to relate it to current. So we will say that Q is nothing, charge is nothing but I into T, current times time. So that Coulomb is nothing but ampere second. So I am writing ampere second over here. So ampere and it will come second cube. And that gives me m raised to 1, L, length, meter is a length raised to 1, time raised to minus 3, this is the time, and this is A, ampere raised to minus 1. And that is the dimensional formula for electric field intensity. Now, properties of electric field intensity. Next property is electric force on a charge Q placed in a region of electric field at any point where the electric field intensity is E is given by F is equal to Q times E. So see, at any particular point, how have we defined E? Electric field intensity is nothing but force experienced per unit charge. Now if you want to get the force, so this is the point where the electric field intensity is A, it is a charge Q is when placed over here is experiencing F vector force, and that we will say F vector is nothing but Q times E vector. So it is important that you remember this relationship. So this is the force experienced by Q charge when placed in E electric field intensity. Now next is electric force on a point charge. On a point charge is in the same direction if it is a positive charge, and it is in the opposite direction given that it is negative charge. So at this point, if this is the electric field is in this direction, if you put a positive charge over here, the force will be in same direction. It's the reverse thing which we are doing. And then if this is the electric field intensity at this particular point and you put a negative point charge, then the force experienced will be in the opposite direction to that of electric field intensity. So again, in this formula, F is equal to QE. If you put your Q with proper sign, so if Q is positive, direction of E and F is same. If Q is negative, then direction of F and E is opposite one. Now next property come to be, it obeys the superposition of principle. So like forces, if we say the net amount of force on any point charge is vector addition of all the forces, then it is force per unit charge only, right? So force per unit charge, that is electric field intensity, will also obey the principle of superposition. So we will say that this is nothing but F1 by Q, this is nothing but F2 by Q, this is nothing but F3 by Q. So we can say this is electric field intensity due to charge 1, this is electric field intensity due to charge 2, this is electric field intensity due to charge 3. And if there are more than one charge is present, at any point we can get electric field intensity due to each, and then we can do vector addition to get the net amount of electric field intensity. Now, let us find the electric field due to a point charge. So this is a point charge which is placed at O, and at this point P, I want to get electric field intensity which is situated at R vector. R vector is the position of this point P with respect to the charge placed regarding, like it is with respect to this particular point O. So now I will say, how do we define it? It is defined as force per unit charge. So see which charge it is. This is a test charge. So for that you have to place a small q over here and get the amount of force. So if we say force on that charge, how much is that? That is K Q1 Q2 by R square and divide by Q. This Q gets cancelled and we get KQ. This is K. 1 upon 4 pi epsilon naught is K. So it is KQ by R square. What about the direction? Direction is same as this R vector. It is basically radially away. So we will say direction is same as R vector. So for direction we are putting R cap in front of it. So at the end the electric field is KQ by R square in magnitude. And if you want to get a vector formula, then you can say it is magnitude times the direction, and direction is R cap.